Okay. Hello, everyone. Good evening. Welcome back to our English class. I hope everyone is doing well. I hope you all are ready for a new topic that we are going to discuss or we are going to learn in this evening. Now, we're going to start with the topic as you can see on your screen. It's all about oil and gas. Okay. I'm just checking if my audio and video is doing fine from my separate device. And it's all good. It's all working well. Okay, good. Now, hello once again, everyone. Again, I've mentioned that we're going to start a new topic this evening, which is all about oil and gas vocabulary. Now, all 25 words, as mentioned there will be 25 essential terms, not just words, but terms that you should know, no, especially if you're a professional in this field, or yes, if you are interested in this field, oil and gas vocabulary, there are 25 essential terms that you need to know. Well, we are going to break these words into different sessions so that it will not overwhelm you because, of course, most, if not all, words are very unfamiliar. Okay, so again, now, why are we talking about oil and gas vocabulary? Now, when we talk about oil and gas industry, it is a massive global sector that is responsible for finding and supplying the energy that makes modern life possible. It is an industry built on advanced engineering, on complex science, worldwide network of facilities, from providing the power for our homes to creating the fuel for transportation. So this industry is the foundation of our current energy system. So oil and gas, if you may not have known, these are natural resources that take millions of years to form. So they began as tiny organisms in, prehistoric oceans that were eventually buried under layers of sediment. And then over time, high temperatures and intense pressure transformed these remains into crude oil, into natural gas. And because these resources are buried miles underground, discovering them requires sophisticated technology. So geologists, and engineers explore the Earth's crust to find hidden reservoirs. So these deposits are often found in some of the world's most remote environments, which include the deep under the ocean floor or beneath massive ice caps. Okay, so there are actually three main sectors to manage such a complex process because getting these things are very complex. So there are three main sectors. So the industry is traditionally divided into three distinct areas, with each has own its specific focus. So first is we have the upstream, which is more on the exploration and the production. This is where the process begins. So teams locate potential oil and gas fields and drill wells to bring the raw resources to the surface. It is a high stakes environment involving massive drilling rigs, which we are going to talk about these terms in our different sessions. We also have midstream, which is on the transportation and storage. So once these resources are extracted, the raw oil and gas must be moved. So this sector involves the use of a giant ship or giant ships, which is the tankers, and extensive networks of pipelines that stretch across entire continents to safely transport energy. So that is on midstream. And then the last one is downstream, which is on refining, on marketing. So the final stage takes place at a refinery. Here, crude oil is refined or cleaned and split into various products. This is also where the final products are sold to businesses and to consumers. Okay? Now, the key part of understanding the industry is knowing how we measure these massive amounts of energy. For crude oil, the standard unit of measurement is the barrel of oil, which we are going to talk about later on. No? Just so you know, the standard size of this one is 1 barrel, which is equal to 42 US gallons or 159 liters. That is the standard size. And then the weight, a single barrel of oil weighs approximately 300 pounds or 136 kilogram. And then in global scale, because the industry is so large, so production is measured in millions of barrels per day, which is MB per day. Okay, so that is basically, an overview of what is oil and gas. Now, it's important that we understand oil and gas, the term itself first, before we go deep into the different 25 essential terms that pertains or under this vocabulary, oil and gas. So while we often think of oil and gas as just fuel for cars or heating for buildings, their impact is much broader. The products refined from oil are used to create essential materials like plastics, fertilizers, for agriculture, and even components for life-saving medical equipment. So this industry is a vital service that powers our technology. So it supports global trade. It enables the high standard of living many people enjoy today. Okay, so that is oil and gas vocabulary. Now we move on, or we start immediately with the first term. Are we all ready? Are we all ready? Okay, let's take a deep breath first so as to really settle ourselves and ready to ingest all this knowledge in this evening. On my cue, inhale, exhale, inhale, exhale. Okay, let it out. Let all the stress of today out. Okay? All right. I hope everybody is settled in and is comfortable enough to really listen to me all throughout our discussion. Let's start right away with our first term. Okay. Our first term is a barrel of oil. Again, barrel of oil. Now, a barrel of oil, as mentioned here, it is a standard unit of measurement for crude oil, which is equal to 42 US gallons or 159. Excuse me. Anyway, let's continue. Again, the standard unit of measurement for the oil, crude oil, is 42 gallons, 159 liters. So, that is on the barrel of oil. That is like defining the standard. So, a barrel of oil is not just a container, it is a precise mathematical definition used to track the lifeblood of modern industry, whether the oil is deep underground, moving through a pipeline, of being traded in a stock exchange, it is measured in these specific units. Now, mentioned here is for the 42 gallon standard. So, a standard unit of measurement for crude oil is equal to is 42 gallons. And then the metric equivalent for those using metric system, that is 159 liters. And then for mass and weight, a single barrel of oil is quite heavy, which weigh, as mentioned earlier, approximately 300 pounds or 136 kilograms. And the measurement is specifically used for crude oil, which is the raw, the unprocessed liquid that comes directly out of the earth. So that is what we call crude oil. Crude as in CRUDE. Crude oil. Not the raw, the one that is not yet processed, okay, or filtered. All right. Now, we've talked, or I've mentioned earlier about BBL, right? BBL meaning blue barrel. What? Blue barrel. Blue barrel. Hmm. Now, I mentioned barrel of oil or the BBL is as mentioned here, it is the um, abbreviation only. Now, the abbreviation BBL comes from the blue barrel, which is the early standard oil plant painted their 42-gallon barrels blue to distinguish them from the other sizes. So that is a fact, as mentioned at the bottom part. Now, when we talk about the BBL or the blue barrel, To understand why the industry uses such a specific number like 42, we must look back at the history of energy production. So the origin of this measurement dates back to the 1860s Pennsylvania oil fields. In the early days of the oil boom, there was no standard way to store or sell oil. Producers used everything from beer barrels to whiskey casks. However, in 1866, a group of producers agreed that a 42-gallon barrel was the most efficient size for transportation and trade. So this size was eventually adopted by the entire industry. So in the industry, again, a barrel of oil is abbreviated as BBL or blue barrel. Now, why two B's? Well, the abbreviation come from B, blue, B barrel. So early Standard Oil painted their 42 gallons barrels blue just to distinguish them from the other sizes that were common at the time. So that is why we use blue here as the color, blue barrel, BBL. Okay? Now, because the world's thirst for energy is so immense, no? There is this overwhelming demand of oil. We do not just talk about individual barrels here. Instead, we look at the total output of entire nations and regions. Now, there is really daily tracking of, barrel of oil. Global production is measured in millions of barrels per day, which is abbreviated as MB over D. As you can see there in the last bullet. Now, of course, since that much is extracted every day, transported every day, there is really a huge economic impact. When you hear reports about the price of oil rising or falling, the price given is for a one single 42-gallon barrel only. And that is very relevant in the present because especially because oil has been the price of oil has been rising these days, especially here in our country. Like you can really feel the impact of, a situation, and it greatly impacted other countries as well, which of course impacted the daily lives of the people in it. No, so that is how impactful the oil is. The price of oil may it be rising or falling, it can really change how people live. Okay, now when it comes to supply and demand, tracking um the MBD helps experts understand if there is enough energy to power the world transport and manufacturing needs. So that is just to balance out supply and demand, because if there might be possibility that demand is too much and the supply cannot keep up for this particular location. So it is important that we try to really track it so that there is just enough supply and there is just enough demand to accommodate to the supply that is established for this specific location. Okay, so the journey of a barrel begins deep in the earth, right? So we had this crude oil. Before a single gallon can be measured, the industry must engage in upstream activities. I mentioned this earlier. Now, what is the upstream activities? We have the exploration, where teams use, some kind of seismic technology to find oil trapped in rock layers. So they are going to explore the earth. And then if they found some, of course they drill once found. And a drilling rig is used to reach the reservoir. So a drilling rig will be talked about later on. And then lastly, we have the extraction. So the crude oil, again, what is crude oil? That is an unprocessed raw oil, no, not yet processed, not yet filtered. So that is a crude oil, the raw one. So the crude oil is pumped to the surface. At this point, it's finally measured and officially becomes a part of the millions of barrels per day count. So again, when we say upstream activities, we have the exploration, trying to find oil, and then once found, we do drilling, and then of course extraction for crude oil. So learning about the barrel of oil is the first step in understanding the global economy. This unit of measurement is the bridge between the raw natural resources found in the earth and the final products we use every day. So it ensures that a buyer in Asia and a seller in the Middle East are talking about the exact same amount of energy. That is, standardizing it. And then it also connects modern technology back to the hardworking pioneers of the 1860s. So that's legacy because again, barrel of oil, especially the blue barrel, the BBL, the unit one, it dates back years, thousands of years ago. And then it helps us also visualize the massive scale of human energy consumption, which is millions of barrels every single day. Okay, all right. Hmm. Okay, let's continue. Let's move on. Again, this is the first term, barrel of oil. Let's move on to the second term, blowout preventer. So the terms, the terms so far, even though there are only two terms yet, it's quite long and not common, especially if you are new to this kind of field. So we have barrel of oil and then now blowout preventer. Again, blowout preventer. Now, what is this? A large specialized valve installed at the wellhead to seal, control, and monitor all oil and gas wells to prevent uncontrolled release or blow out. Okay, so we have the blowout preventer. Oh no, I just noticed. I am so sorry. The slide is cut. Anyway, let me show you again the barrel of oil. So that is a barrel of oil. Just so you have, a reference on the details that were cut off earlier, because I wasn't able to really check on the particular, slide. Now, anyway, let me check again. Okay, it's all good. Thank God. Let's continue with a blowout preventer or BOP. This is, as mentioned there, a large specialized valve installed at the well head. So think of it as the ultimate safety switch for an energy well. Its primary job is to seal, to control, to monitor the oil and the gas wells to prevent, uncontrolled release of pressure, which is known as the blowout, as mentioned here. So it is basically a critical safety device. So the BOP or the blowout preventer, it is considered the last line of defense against environmental disasters and rig accidents. So the scale is really enormous. These devices are not small valves. A single BOP stack can weigh up to 400 tons. That's how enormous the scale is. And of course, since it's really, enormous, it's a big responsibility, there should be a legal requirement. And because they are so vital for safety, BOPs are required by law on all drilling operations worldwide because again it is a critical safety device. So how important BOP is, how the BOP works, how does the blowout preventer works. So again, the BOP is designed to handle the most extreme conditions imaginable. It sits directly on top of the well and remains active throughout the entire drilling process because we don't know really what will happen in the first few process of trying to drill the earth. We don't know what will happen, so that's a critical safety device, the BOP. Now, there are multiple layers of protection. A BOP stack contains multiple ram and annular preventers. When we say annular preventers, these use a large rubber ring to seal the space around the drill pipe. And we also have ram preventers, which is these use the steel blocks or rams to physically squeeze the pipe shut or in an emergency shear or cut the pipe completely to seal the well. Okay, so they use that one, multiple layers of protections. We also have rapid response. In an emergency, every second counts, right? So a modern BOP can seal a well in under 30 seconds. And they also have pressure testing, so to ensure that they never fail, modern BOPs undergo strict pressure testing every 14 days. Okay? So the history of the blowout preventer changed forever, following one of the most famous events in energy history. After the Deepwater Horizon disaster in 2010, BOP regulations were significantly strengthened worldwide because they cannot risk it twice. So engineers realized that these devices need to be even more powerful and reliable. So that today the BOPs used in offshore drilling, they are really monitored 24/7 by experts on the surface and even by remote sensors deep underwater. So this constant monitoring ensures that the pressure inside the well is always under control and it would not risk the life of the workers. Okay? So, of course, BOP is really essential because the blowout preventer, it is a vital piece of equipment because it allows the industry to explore high pressure areas that would otherwise be too dangerous to touch. So it is a symbol of the industry's commitment to protecting nature and keeping the environment clean. Because by preventing blowouts, the BOP or blowout preventer ensures that oil and gas stay inside the pipes and do not leak into the ocean or the surrounding land, which can be harmful to the environment. So there is really environmental protection here, not just the people are protected, but also the environment. We also have, as mentioned, there is, the people are safe. There is worker safety, as it creates a secure environment for the busy activities of the crew on the rig floor. And of course, reliability is a big thing. Knowing a blowout preventer is in place allows engineers to work with confidence, even when drilling in deep water or through tough rock. So we try to master energy safety. Okay. And everything that we do, we always prioritize our safety, especially if it's, a dangerous job. So by learning about the blowout preventer, you are discovering the side of the energy industry that focuses on responsibility and protection. It is an engaging subject because it shows how human engineering can master the incredible forces of the earth. So again, we have sealing, what was mentioned here, sealing, control, and monitoring. Okay, so we seal to close. When we say sealing or seal, that is to close the well completely. Control, it is to manage the flow of the fluids, and of course monitor, that is to keep a close watch on pressure changes. Okay, again, that is blowout preventer. Okay, next term, we have the casing head gas. Again, casing head gas. Now, what is the casing head gas? As defined here, natural gas produced from an oil well, dissolved in crude oil underground, or released to the surface as pressure decreases. So, a casing head gas is a type of natural gas that is produced specifically from an oil well, as mentioned here. It exists as a gas that is dissolved in crude oil while it is deep underground, under high pressure. So there is really the release because as the oil is brought to the surface, the pressure decreases. So the the deeper the oil is, the deeper you try to explore the earth, the higher the pressure is, which is of course not good. So, as mentioned earlier, when the oil is brought up to the surface, the pressure decreases. So, much like opening a bottle of soda, the gas bubbles out and is released at the surface. So, there is, of course, a collection point. This gas is collected at the casing head, which is the very top of the well casing. You might also hear this gas referred to as associated gas because it is associated with oil or wet gas. And of course, what is inside the gas? Well, casing head gas is different from the dry natural gas used to heat homes. It is often described as rich or wet because of its chemical makeup. There is heavier hydrocarbons in addition to methane. This gas contains heavier hydrocarbons like butane and propane. And because of these extra components, casing head gas can be processed to extract natural gas liquids or NGLs. These liquids are very valuable for making plastics and special fuels. And the way industry handles casing head gas has changed dramatically over the last century. In the early days of energy production, companies only cared about the liquid barrel of oil. Since in early oil fields, casing head gas was often flared or burned off as waste because there was no way to transport it. This created giant towers of fire at oil sites. And today we know that this gas is far too useful to waste. It has become a valuable source worth billions of dollars annually. So that is the modern value of it, not the casing head gas. And instead of burning it, which is how how it was done in early oil fields, modern companies use blowout preventers and specialized collection systems to ensure that this gas has or is captured and sent to the market so that for profit. Now, why casing head gas is important? Well, understanding casing head gas helps us see how efficient the energy industry has become. By capturing the wet gas that bubbles out of oil, we are able to get more energy and more products out of every single well. Now, there are multiple products. Basically, one well can provide a barrel of oil and a large amount of casing head gas at the same time. So there are multiple products for one well. And of course, there is raw materials in the sense that the butane and the propane extracted from this gas are essential for manufacturing items we use in our daily lives. And managing the release of this gas is a key job for the blowout preventer, which was mentioned earlier, BOP, and it helps to monitor the pressure as the gas expands near the surface. So that is casing head gas. So um, we understand that when we talk about casing head gas, the energy production of one well is about more than just one product, the barrel of oil, and then the second one is casing head gas. So it is about a busy environment where multiple resources are managed at once to keep our world running. So there is three essential terms that you also need to know under casing head gas. We have the dissolved, which is mixed into the oil underground. We also have associated, which is found together with oil, and of course valuable, which is a resource that provides billions in value and important liquids like propane. Okay, that is what? That is the casing head. That is the casing head gas. Okay, all right, let me check on you. Are there any questions? Let me check on the stream. Okay. I think there are no questions. No, I would really appreciate it if you have any questions so that I can answer it or address it. You can always use our chat box for confusions, any kind of confusions, responses that you want to provide. I will constantly check it, okay, from time to time. Anyway, let's move on to the next one. Catalytic cracking. Again, catalytic cracking. Now, what is catalytic cracking? As mentioned here, it is a refining process that uses heat and catalysts to break down large, heavy hydrocarbon molecules into lighter, more valuable products. So, um, basically, catalytic cracking is one of the processes that modern people use when we try to talk about the process of turning raw thick energy into the powerful fuels we use every day. And that is, as we know, it is really a remarkable feat of chemistry. So one of the most important methods used in this transformation is what we call the catalytic cracking. Again, catalytic cracking, it is a refining process. It is a high-tech refining process which is used to break down large, heavy hydrocarbon molecules into lighter, more valuable products, as mentioned there. So, crude oil, which was again the definition, the raw unprocessed oil, This kind of oil is measured in a barrel of oil. So it contains many different types of molecules. Some are light and easy to use, while others are very heavy and thick, like tar. So to make enough fuel for everyone, refineries use catalytic cracking to crack those heavy molecules apart. Okay, we have the heat and catalyst. So the process uses intense heat and special substances called catalysts to cause the chemical reaction. We also have zeolite catalysts. So modern refineries often use zeolite catalysts to make sure the process as efficient as possible. And of course, the extreme temperatures. This kind of reaction takes place at a very high temperature, typically between 900 to 100 degree Fahrenheit or 480 to 540 degrees Celsius. And the main goal of the catalytic cracking is to create a fuels that power our world because before this process was invested, refineries could only get a small amount of gasoline from a barrel of oil. So catalytic cracking, it really creates or converts heavy crude oil fractions into gasoline and diesel. So which are the key products of it? And then this process is so effective that it has produced about 50% of all gasoline in the US. So that is a massive impact. And of course, high quality. It is specifically known for producing high octane fuels, which are better for modern engines. And a history of innovation, we know that getting oil has not been very easy from the start, but there is huge progress, no huge difference in the present. So the development of catalytic cracking changed the course of history. It moved refining away from simple boiling into the world of advanced molecular science. So, who was the inventor of this one? The process was invented by Eugene Howdry in 1937. No? Catalytic cracking was a crucial part during World War II because it allowed for the mass production of high octane aviation fuel for planes. So today, this process is used in almost every major refinery to ensure that we get the most value out of every drop of oil, including the casing head gas that is captured at the well. Okay, so catalytic cracking in the industry, it is the part of the downstream sector of the energy industry. It takes place after the oil has been safely managed by a blowout preventer at the well and transported via pipelines. So the refinery here, it takes crude oil and heats it up. So that is, refining the raw material. And then after that, we step inside. Okay, we step inside a giant tower. The heavy oil meets the hot catalyst, so the molecules break apart instantly. So that is the cracking step. And last one is separation. The new lighter molecules are separated into gasoline, diesel, and other useful gases, which is now sold, not to people. So without this process, without catalytic cracking, the world would be would be or would face a major shortage of fuel. And by using zeolite catalysts and extreme heat, we can um, transform low value heavy oil into the essential energy that prevents prevents or that powers heavy oil into the essential energy that powers our transportation and industry. Okay, so it really allows us to get the maximum amount of usable fuel from every barrel of oil, and it turns cheap, heavy parts of oil into more valuable products like gasoline. And of course, it shows how chemistry can be used on massive scale to solve global energy needs. So basically, science in action, and that is catalytic cracking. Okay. Now, so far we've talked about barrel of oil, which is a standard unit of measurement for crude oil, which is equal to 442 US gallons and 159 liters. And then we also have a preventer, a catalytic, a critical safety net. And then we also have casing head gas. And last one is catalytic cracking. Let's do a 5-minute break and let's continue by 6:40 p.m. See you, everyone. Because I guess it's really overwhelming. Okay, that is catalytic rocking. Okay, goodbye, everyone. See you in 5 minutes. No, take a proper rest. You can drink your water. Take a quick nap of 5 minutes. Let me just off my cam first. Oh no. Okay, welcome back, everyone. I hope you all had a quick rest. You are already hydrated. You have drunk your water, and biological break also. Okay, now let's continue with another term. We have directional drilling. Let me just check if everything is working. Okay, everything is working well. All right, let's continue with directional drilling. Now, what is directional drilling? As mentioned here, it is the practice of drilling non vertical wells, intentionally deviating the well bore along a planned path to reach targets not directly below the surface location. Basically, directional drilling, it is the practice, as mentioned here, of drilling non-vertical wells, which is, unlike traditional methods that only go straight down, this technique involves intentionally deviating or going away from the wellbore along a planned path to reach targets that are not directly below the surface location. So there is, if I may say, flexible angles, because modern technology allows engineers to drill at various angles, which includes reaching a full 90-degree horizontal turn. There's also this is also a method that can reach reservoirs that are located miles and miles away from the actual surface drilling site. And of course, it allows, excuse me. Anyway, there is basically precise targets. No, it allows um it allows for single drilling rig to hit multiple specific sweet spots in an oil or gas formation without moving the entire setup. Well, of course, that is still not familiar. So how does directional drilling works? Well, moving a drill is a bit along a curved path. It really requires much more than just the standard motors. We have here specialized tools, no? So directional drilling relies on a high-tech downhole equipment to navigate deep underground. We have, instead of rotating the entire drill pipe from the surface, specialized mud motors are used. These are powered by the force of the drilling fluid, which is the mud, flowing through them, allowing allowing the bit to turn independently. We also have engineers that use measurement while drilling, or MWD tools, to get real-time data. So these sensors tell the crew the exact direction, angle, the location of the drill bit thousands of feet below the earth. And these tools also allow the operator to steer the wellbore in real time, so adjusting the path to stay within the most productive part of the rock. So there is steerable systems. Okay, so those are different specialized tools to really accommodate to this particular, drilling method, directional drilling. And of course, one of the greatest advantages of directional drilling is how it changes the footprint of energy production in our landscape. It reduces footprint in a way that this technique reduces the environmental footprint because it allows the drilling multiple wells from just one pad instead of having dozens of individual drilling sites across the field. You can have one central location, which is much more environmental friendly, and it allows companies to reach resources located under protected areas such as um, sensitive wildlife habitats, or even under a town or a city without disturbing the surface above. So it avoids obstacles basically. And of course, there is maximum production in a way that if we turn the well horizontally, the drill stays in contact with the oil bearing rock for a much longer distance, which significantly increases the amount of energy collected compared to a vertical well. So the scale of directional drilling is truly staggering in a way that as engineering improves, the distances these wells can travel continue to grow. So there are, record-breaking achievements. So the longest horizontal well ever drilled extends over not 400, but 40,000 feet, which is 7.6 miles, longer than the depth of the Mariana Trench. Okay, that's how um, record breaking the achievement of directional drilling is in the modern day. No? So to put that in perspective, again, it is longer than the depth of the Mariana Trench, which is the deepest part of the ocean. Okay, so understanding directional drilling is a really key step in seeing how the upstream sector of the industry has evolved. It shows that getting a barrel of oil to the surface is a feat of extreme precision and safety, because we have, again, I mentioned earlier about deviating. No, we intentionally change the direction of the well bore. What direction? Horizontal. We drill at a 90-degree angle to stay inside a specific rock layer. And of course, we well bore in a way that the actual hole that is drilled to reach the oil or gas that is well bore. So by using this technology, the industry can really operate more efficiently while doing a better job of protecting the Earth's surface. It is an example of how busy activities underground can be managed with minimal impact on our daily lives above. Okay, that is directional drilling. Next, we have drill bit. Okay, now drill bit, as mentioned here, the cutting tool attached to the bottom of the drill string that breaks rock to create the wellbore. So to reach energy resources buried deep underground, the industry relies on one of the most durable and high-tech tools ever engineered, which is the drill bit. This equipment is at the very heart of the upstream sector, performing the essential work of clearing a path through the Earth's crust to reach valuable oil and gas deposits. So, again, what is a drill bit? It is a specialized cutting tool attached to the bottom of the drill string. So, its primary job is to break the rock and create the well bore, which is the actual hole that allows for the extraction of resources. So, there is a cutting action because as the drill string rotates, the bit grinds, the bit crushes or cuts through various rock layers. And depending on the type of rock formation, the bit can rotate anywhere from 60 to 300 RPM or revolutions per minute. So these are the precision engineered tools that can cost anywhere from $5,000 to over $100,000 each. Okay, well that's understandable co- um, considering the how high tech it is. Okay, so there are actually different types of drill bits, though not mentioned here. Yeah, I was mentioned here. Roller cone, fixed cutter, or PDC bits. We also have diamond bits. So those are different types of drill bits because different parts of the earth have different types of rock, from soft clay to solid granite. So of course, engineers must choose the right bit for the job. So what is the first one? That is the roller cone bits. These have cones that spin and use teeth to crush the rock. That is roller cone. We also have fixed cutter or PDC bits. These use synthetic polycrystalline diamond or PCD cutters and have no moving parts. And last one, diamond bits, which is used for the hardest formations. So these use industrial diamonds to grind through the surface. Okay, so did you know modern PDZ drill bits are so strong that they can drill through solid granite? So the synthetic diamonds used on their cutters are among the hardest materials ever manufactured. That's how strong it is. So how does the drill bit look like, no, in action? The drill bit is the pioneer of the entire energy process. Its success determines how efficiently a company can reach its goal. So, in directional drilling, the bit can be steered using specialized mud motors to reach targets that are not directionally below the surface, or navigation basically. That's the main of directional drilling. While the bit creates the path, the blowout preventer remains ready at the wellhead to manage the intense pressure that a bit might encounter deep underground. So, for safety, again, that is BOP. And once the bit has successfully reached the reservoir, the industry can begin capturing the barrel of oil and the casing head gas that bubbles out of it. Okay, so uh, what are the different vocabularies mentioned under the drill bit? So, so as to understand the intense physical labor and precision science required to power our world. We have well bore, so the hole created by the drill bit that is well bore. PDC, that is a type of bit that uses synthetic diamonds for maximum cutting power. So that is really strong. And then we also have RPM, which is how fast the bit turns to break through the rack. Okay, that is drill bit. Okay, let's move on to the next one. Drilling fluids. Okay, drilling fluids, specially formulated fluids, also called drilling fluids, circulated through the drill string and wellbore during the drilling operations. That's the definition. Because the process of extracting energy from deep within the earth is a complex engineering challenge that requires more than just a powerful drill. So, to keep a well running safely and efficiently, engineers use a critical substance known as drilling fluids, which is also known or referred to as the drilling muds, because these are formulated liquids that are circulated through drill string and well bore during drilling operations. They are far more complex than simple water. They are precisely engineered chemical mixtures designed to perform multiple life-saving and efficiency-boosting tasks deep underground. So there is really a circulation path. The mud is pumped out through the hollow drill pipe. It exits through the drill bit and then flows back up to the surface through the space between the pipe and the well wall. So there is also, of course, constant monitoring because the condition of the mud is so important. It is monitored by mud engineers 24/7. Okay? Why? Because this is just to ensure that the its properties remain correct for the specific rock layers being drilled. And yeah, that is drilling fluid. Well, there are four vital functions of drilling of mud, because without drilling fluids, it would be nearly impossible to reach a barrel of oil safely. So the mud performs several critical roles at once. First is we have for cooling and for lubrication, because drilling through thousands of feet of solid rock creates immense friction. So the fluid serves to cool the bit and lubricate the entire drill string, preventing the equipment from melting or from snapping. And then, as the bit grinds through rock, it creates small pieces called cuttings. So the thick drilling fluid is designed to carry cuttings back to the surface so that the bottom of the hole stays clean for the bit to keep working. Okay? All right. And then we also have maintaining the wellbore pressure. This is perhaps the most critical job. The weight or density of the mud helps maintain wellbore pressure, which keeps underground fluids like casing head gas from rushing into the wall uncontrollably. So that is for that, for safety, the most critical job. And then we also have wellbore stability. The fluid creates a thin layer of mud cake in the walls of the hole, which prevents well from carving in one carving on itself. Okay. Now there are different types, and let's say discovery. So the science of a drilling mud has advanced significantly since its accidental discovery. So it was really not intentional, not the discovery of drilling fluids. How is it accidental? Well, drilling mud was discovered by accident when a Texas driller noticed that muddy water flowing into a well stopped it from caving in. So today there are three main types of drilling fluids used depending on the environment. So these are the different modern formulations. We have the water-based, the most common and environmental friendly. We have the oil-based, which is used for very deep or hot wells where extra lubrication is really important or needed. And then it is specially engineered to provide high performance with lower environmental impact or synthetic based. So when it comes to the density range, to manage different underground pressures, the weight of the mud can range from 8.5 to 20 plus pounds per gallon. Okay, so that's just an overview of that. And we always talk about safety, right? So safety and the drilling system. Well, drilling fluid is the first line of defense in well control. It works alongside the blowout preventer to keep the how do you call it to keep the rig safe. So while the BOP is mechanical valve used in emergencies, the drilling mud provides how do you call that provides primary well control by using its own weight to put or to push back against underground pressure. So we try to manage pressure. If an engineer detects that pressure is rising, they can weigh up to the mud to increase the downward force. By maintaining a stable hole through directional drilling paths, the mud ensures that the wellbore remains open and secure for miles. Okay, for a moment. Okay, all right. So that is safety. That is drilling fluid. Very complicated since drilling fluid is really the first, how do you call that, line of defense in well control. It works alongside the blowout preventer or the BOP to keep the rig safe. So when the BOP is a mechanical valve used in emergencies, the drilling mud provides primary well control by using its own weight to push back against underground pressure. Okay? Because the density range is that to manage different underground pressures, the weight of the mud can range from 8.5 to 20 plus pounds per gallon. Okay? Okay. Now, for safety, we always try to manage the pressure. If an engineer detects that the pressure is rising, they can weigh up the mud to increase the downward force. So we try to protect the well by maintaining a stable hole through directional drilling. But the mud ensures that the well bore remains open and secure for miles. So why does drilling fluids really matter? Because it shows that drilling is not just about force but about chemistry, pressure engagement, and all those things. So the long chain of pipes that carries the mud and turns the bit, well, that is what we call the drill string. Okay, long change of pipes. And then we also have well bore, which was also defined earlier. The well bore is the actual hole in the ground where all the action happens. And lastly, we have the mud engineers, the specialists who ensure the mud is always ready for the job. So by using specifically formulated fluids, okay, the industry can really drill deeper. They can stay down longer and they can safely bring the energy the world needs to the surface. Okay, that is our last term for the day. Again, we've talked about oil and gas vocabulary. Now, there will be 25 essential terms that we're going to talk in different sessions because we cannot finish in one session alone, considering that the terms are really not familiar to all. So I'm trying hard to really do that, to make it simpler to use so that it would be very understandable. But anyway, what did we discuss this evening? We have again our focus in this week will be oil and gas vocabulary. We talked about barrel of oil, blowout preventer, kissing and cause, catalytic cracking. Oh no, your brother is learning low. Anyway, catalytic cracking and directional drilling, as well as drill bit and drilling fluid. So there were one, two, three, four, five, six, and seven terms that we've discussed in this evening. Are there any questions about the discussion? Are there any questions? Well, if you have one, we can always address it in the next meeting. In the next meeting, we're still going to continue with oil and gas vocabulary because we still at seventh word or seventh term. So we're going to continue tomorrow with this with the same discussion or same topic. Okay? That is all for today, everyone. Goodbye and have a great rest of the night ahead. Good evening.